shortcuts, we've looked at the first one in the proof. It's f of x equals to x to the nth power. So the derivative there was n times x to the n minus 1, correct? Again, understanding this, x is your domain, n is a number. So based on that information, it's different when we get to f of x equals a to the x power. You're going to use a different shortcut for that. Now, example of the first shortcut, again, this is the power rule. If I have f of x equals, let's do 1 over x. We did this one earlier in class. How do we treat 1 over x? It's also the same thing as x to the negative first power, right? So let's do our shortcut. F prime of x is equal to, all right, it's n, and n is negative 1, so we get negative 1 times x to the, so we've got negative 1 minus 1, which would be negative 2. So we would get negative 1 over x squared. The other day we did that using f of x plus h. A lot quicker doing it like that. But that is an example of the power rule. Now, the next shortcut is called the constant rule. So if f of x is equal to a constant, we'll just call this constant c. F prime of x is going to equal to 0. Now, why do you think that that would be, graphically speaking?
Because there's no slope. Because it's just one line that stays the same the whole time.
You've got a horizontal line, right? Anytime f of x is equal to a constant, you're talking about a horizontal line. And the slope of a horizontal line is 0. All right? So we got 2 shortcuts down. Well, here, let's look at an example. F of x equals 2. That's a good number. So f prime of x would be 0. All right. That's the constant rule. The next one's going to be the constant multiplier rule. If f of x is equal to a constant times a function, let's just say it's times g of x. So f of x is going to equal to a constant times g of x, then f prime of x is going to equal to the constant times g prime of x. I'm going to do 2 examples with this one. First example I'm going to do is f of x equals to, let's make it 3x to the 5th power. All right, my constant is 3, and my g of x is x to the 5th power. So I'm going to break this down into, I've got 3 times. Now, how do I handle the derivative of x to the 5th power? Well, it becomes 5 times x to the 4th power. So it's times 5 times x to the 4th power, which would be 15x to the 4th power. And there's a good chance that you would have known to do that without me even saying that, but doesn't hurt to say. What about f of x equals to 2 sine of x? Think about what 2 sine of x is. 2 sine of x is the sine curve, but it's twice as, the amplitude's twice as much. So let's get the derivative of it. Well, the constant is 2, right? And what did we say earlier that the derivative of sine of x is? Cosine of x. So f prime of x would be 2 times the cosine of x. And then finally, we've got the addition and subtraction shortcut. And it says if we have f of x equals to g of x plus h of x, then f prime of x is going to, I should say plus or minus. F prime of x is equal to g prime of x plus or minus h prime of x. Look back at your homework from last night and give me one of those polynomials that we had for homework last night.
X squared plus 3x.
X squared plus 3x. So we're adding two different functions together, right? Well, so let's take the derivative of the first one and let's take the derivative of the second term. So f prime of x is going to be, all right, what would be the derivative of x squared? Well, what's in? 2. So it'd be 2 times x to the first power, which is x. Now, what about 3x? This would be my h of x. All right, well, what's my exponent with 3x? 1. So it'd be 3 times 1 times, and what's 1 minus 1?
0.
0. And what is x to the 0?
1.
1. So my answer is 2x plus 3. And look and see what you got for your answer for homework. Should have got 2x plus 3.
Huh.
This 0 here, this had an exponent of 1 with it. And remember, you subtract 1 from whatever your exponent is.
So everything goes back to the first. We gotta always use that first one, unlike all the problems.
If you're dealing with the power rule, you go back to this. Yes.